Hi everybody and welcome to this tutorial focused on the LoRaWAN certification. I'm Itziar de la Torre from IMST and working at the Wireless Solution Department. Firstly, I will give you a quick introduction about the LoRaWAN certification process, and then I will guide you through the LCTT testing tool, which has been recently recognized by the LoRa Alliance as the official certification tool to be used also by the authorized test houses. Therefore, this could be really helpful for you if you are planning to prepare your product for the LoRaWAN certification. Let's start explaining what the LoRaWAN certification is. This is a program that checks that the end device has been implemented compliant with the LoRaWAN specification. This ensures its correct behavior in a real LoRaWAN network. Here, it's important to remark that the ongoing LoRaWAN certification is only valid for end devices. Currently, in LoRaWAN version 1.02, only Class A devices can be certified. On the other side, the LoRaWAN version 1.04 includes the certification of Class A, Class B, and Class C devices for all regions defined in the Regional Parameters document. After a successful result, the end device could carry the LoRaWAN certified mark and will be included in the LoRa Alliance promotional marketing. This is valid for LoRa Alliance members or certification affiliates. Everything you need to run the LCTT tool is a PC, a LoRaWAN gateway, and your end device. If you have finished the design of your product and you are interested in getting it through the LoRaWAN certification, the LCTT tool may be an interesting option for you. This tool has been developed by the LoRa Alliance to allow an easier pre-testing of the devices before sending them for the formal LoRaWAN certification. To obtain the LoRaWAN certificate, you just need to follow a few steps. First of all, you could contact the LoRa Alliance to get the LCTT tool and its license. The LCTT could help you to validate your product and prepare it for the LoRaWAN certification. It's important that additional to the standard LoRaWAN application, the end device implements the certification protocol, which uses the port 224. Thanks to this test application, the testing tool can automatically run several tests to ensure the correct LoRaWAN behavior. In addition, the end device will be configured to be automatically LoRaWAN activated after its reset. After that, you should contact the LoRa Alliance authorized test house. They will send you a quote and a questionnaire, which you need to complete with information of your end device. You could also arrange a testing schedule. Once you have your product ready, you have to send it to the test house. And don't forget the retransmission spec of testing for LoRaWAN version 1.04. The test house will run the test in an anechoic chamber using the LCTT as official testing tool, and it will share with you and with the LoRa Alliance the successful results. Finally, you will get your certificate within few days. If your product is based on an already LoRaWAN certified module, you may request the LoRaWAN certification by Similarity, which simplifies the LoRaWAN certification process. The main difference here is that this process does not require any testing run by the authorized test houses. Only a quick testing using the LCTT is needed in case your product is compliant with the LoRaWAN version 1.04. This could be run by each member and ensures the correct integration of the certified module. In this case, the authorized test house reviews the logs and the documentation, including the self-declaration form, before sending the whole information to the LoRa Alliance. After the successful certification, your product will be included in the LoRaWAN showcase of the LoRa Alliance. This contains some identification of your device, as well as the information related to the LoRaWAN certification, like the version of the LoRaWAN specification and the regional parameters document used, and the end device operation class. Once you have your end device ready and the LCTT tool installed on your computer, you should configure the LoRa packet forwarder available in GitHub on your LoRaWAN gateway. For this, basically everything you need is to connect the gateway to your computer using the Ethernet cable and connect it via SSH for its configuration. Or even easier, the LCTT has been updated to provide a remote configuration of your LoRaWAN gateway to ensure that your setup is compatible for a successful execution of the test. Now you only need to start the LCTT tool and configure it as follows. If this is the first time you run the LCTT, you should start upgrading its license. You will get the license file from the LoRa Alliance after sending the generated file. After that, you could check that everything has been correctly installed if the software requirements are fulfilled, and then select the technology package you would like to use. Note that once a new release is available, it will be automatically downloaded and installed by the LCTT, and it's also recommended to use it. The next window offers you the possibility to export and import a project, which could be helpful after the installation of a new technology package or just to exchange some results with your college. Here we will start creating a new project. The first step after creating this project is to assign a gateway. If your gateway is not listed by the LCTT yet, you could create a new one. In this case, we will create a new IMST Lite gateway and we will enter its information in the corresponding fields. If you are interested in the remote configuration of the gateway, it's important to enter the file path to copy the configuration file for the LoRa packet forwarder and also the command to start it. After selecting the gateway, the LCTT requires some details about your setup to be able to create the configuration file for the gateway. Those parameters are the LoRaWAN regions you are interested in, the LoRaWAN version, and the testing purpose. Here, the certification testing is the option to be used by the authorized test houses, and this is only available if some requirements are fulfilled. For example, you need a 64-channel gateway to test a fixed channel region. On the other side, the pre-testing option is available with any setup. Then you should set the Server UDP port and the IP address of the gateway. As server address, you should enter the IP address of the computer where the LCTT is running. You could check that all parameters are correct in the next window. In the next step, the LCTT will configure remotely your gateway with the correct configuration for the test. Firstly, I would recommend you to check on your gateway the permissions and the correct access to the file system. And if you are using our IMST Lite gateway, please follow our quick start guide for this. The first two parameters correspond to the LoRa packet forwarder parameters that we have already introduced previously. Here, it's important to remark that the format of the configuration file is slightly different depending on the chip built on your gateway, and therefore you should select here the correct one. After entering the access data for the gateway, the setup could begin and the LoRa packet forwarder will be automatically started. In the next step, you could check that the communication with the gateway is working properly. Next, we will assign a device to our project. For this, we will create a new device and update its Boolean parameters. We will select the parameters of our end device. For example, we will start with the European LoRaWAN region, LoRaWAN version 1.04, Class A and Class C testing, including the over-the-air activation. As non-Boolean parameters, we will enter mainly the activation parameters. In this case, we will use the over-the-air activation, and therefore we will skip the first three parameters for activation by personalization. Once we select our device, only the test cases applicable for our setup will be available. In this case, the test cases for Europe, LoRaWAN version 1.04, Class A and even Class C are shown. Here, the All Applicable Test Cases option can be used if you want to run the complete LoRaWAN certification. But for this demo, we will run only the encryption test case after the device activation. Now we have everything ready to start our test. The first pull data indicates that the communication with the gateway works properly and the end device can start with the over-the-air activation. All LoRaWAN messages sent by the end device and the LCTT will be shown in the trace window. After a successful activation, the LCTT will use the test mode commands to run all test cases sequentially. For this, after the first uplink, the LCTT will send a downlink to the device to activate its test mode or configure its uplink periodicity. You will see the results for its test case after their completion, and the trace log folder will contain all log files. If an authorized test house is running the test for the LoRaWAN certification version 104, the certification port must be deactivated before sending the product back to the customer. The LCTT also includes this test case. Once you have finished your test, you could create the test report, including your selection of the test cases. This contains a brief overview with the final results and some additional information related to the LCTT version that has been used. Here you could also find the details of all LoRaWAN messages sent, including the radiation parameters used, like frequency and the data rate. This will help you to understand and analyze your issues if you find some. If you would like to request the certification by Similarity for your product for LoRaWAN version 104, additional to the self-declaration, you will need a quick testing available in the LCTT. For this, you should create a new project and go through its configuration similar to the previous example. After selecting the gateway, you should enter your setup configuration and choose the Similarity testing option. If the LoRa packet forwarder on the gateway is already running with the correct settings, you could skip the next windows and continue with the end device selection. Now, the certification by Similarity test case is available and you could start its testing. After a successful activation, you should follow the instructions of the LCTT and reset your end device when required. For this testing, the certification protocol running on port 224 is not needed and the whole testing is run using the standard application. The only requirement is that the end device is configured to send uplinks periodically, and it's recommended that the device is set with a faster periodicity for a quick execution of the test. For example, this could take less than 10 minutes if the uplinks are sent every 10 seconds. If you are interested in the LoRaWAN certification for version 104 and your product uses the over-the-air activation, you need the additional retransmission spec of testing. This is also available within the LCTT. Similar to the previous examples, you could start creating a new project, choosing your gateway, and setting your setup configuration. In this case, the spec of testing should be selected. Once the end device is assigned to the project, the retransmission spec of testing could be started. After the successful activation, you should follow the instructions of the LCTT and reset your device when required. This test takes 35 hours and checks that the transmit time of the joint request follows the limits defined within the retransmission spec of section. You must ensure that the device under test does not reset itself during this period. The new user interface of the LCTT provides the support of multiple gateways. This is quite useful for a full testing of a fixed channel region, such as North America. For example, you could create a new project, assign one gateway model, and enter your setup configuration. Here, you could connect 8 different gateways and introduce their IP address. In the next window, you could check that the parameters are correct, and the following step will configure the packet forwarder of each gateway with the correct configuration file and will start automatically the application on all gateways. Then you could check that the communication to all gateways is working properly. Similar to the other project, a new end device is required. Then you should introduce the Boolean parameters like LoRaWAN region, LoRaWAN specification and operation mode, and its activation mode. Here we will use again the over-the-air activation and we will enter its parameters as the non-boolean parameters. Now the test cases applicable for our setup are shown. For example, we could start with the activation test case. Here, the communication with all gateways is achieved after the reception of all pull data. This means that everything is ready and the end device could start joining the LoRaWAN network. The next steps will be run automatically and no additional interaction with the end device is required. Finally, I would like to mention that some test cases require some specific parameters that could be modified by the user. Of course, this applies to all regions. Besides the LoRaWAN certification, further testing may be interesting for your LoRaWAN product. For example, you may request the LoRaWAN certification by Similarity if your product includes a LoRaWAN certified module or end device. Additionally, the radiation performance testing provides the full radiated power and the sensitivity information of the devices. For this, you should also contact the LoRa Alliance authorized test house. And don't forget that the regulatory testing is not part of the LoRaWAN certification process, but this approval is also required if you would like to release a new product to market. This can take place before, after, or at the same time with the LoRaWAN certification testing. And if you still have any question or you need further assistance, please contact us at IMST. We can offer you technical support in every phase of the development and certification process. I hope you enjoyed this tutorial and thank you very much for watching it.